Ugh, I forgot my water. Here, my water. Once you started streaming, you can't stop. Ooh, I almost forgot my water. All right. So, oh, great. Current filter type, right. Current, I'm pretty sure that's supposed to be. All right, oh. Let's make sure. Okay, it looks like we're up on YouTube, up on Twitch. That is not this stream, it's the previous one. And, oh yeah, I think Twitch is live too. And YouTube is up and running. Alrighty. So, thanks for the support, by the way, guys. I always appreciate it. Particularly my news. Okay, so what did we do this morning? Ah, yes, this morning we enabled dragging of elements, right? So we already have the line editing. Excuse me. I think I'm gonna quickly squeeze in the underlay objects as well, because that might start giving us some idea of how to deal with overlapping selections and such. And I think we can just collapse all these. Yeah, I think one on level 3. No, level 4. Yes, level 4. So we've had an underlay component. Do I want a separate component for underlays? Are underlays significantly different from overlays? Maybe we can inherit from overlay. So what if I do this? Right, and then, yeah, so this is the overlay. This will be the underlay. Because overlay and underlays are really just separate layers. I think their functionality is identical. The only difference might be that we might want to have slightly different selection code, and that it obviously potentially looks in a different place. So what I'm gonna do is I'm gonna inherit from the overlay component instead of from. So I'm gonna inherit from overlay to create underlay. And for now, all the stuff is just gonna go, oopsies. Whoops. And there is a function. See, get component data. Yeah, that's it. So that's the thing that actually determines where the data comes from. And it's going to be underlays. Wait, why does this keep... I'm pressing Ctrl S. Why doesn't it just save? What the hell? Why does it think this is a different file? Wait a second. No. Tool editor. Save. This is identical. What the heck is going on here? That is mildly worrying. the heck? I mean, that looks like that's what should be here. Very strange. Huh. Very strange. All right, all this deprecated stuff we want to get rid of. Why does ah man, this multi-selection. I don't know what they've done in this update, but they screwed up all of my habits. That is so annoying. Anyway. Don't blame the tools, as they say, right? So, open current puzzle, and we're going to add the underlays. In fact, the underlay shouldn't it be first? Which order do we want? Doesn't matter. It shouldn't matter. I hope it won't matter. So now we should be able to select these and, you know, put this thing there. Oop. Ah, the selection outline is layered, Z layered, but we might be able to fix that with Z indexing the pseudo element, maybe? Ugh, it's a filter. Shoot. CSS filter Z. Ah, but excuse me. Maybe we could just bring this higher up. WebKit filter hover. Why does stacking order change on WebKit filter hover? One thought I have right now is, I mean, I can change the index here. The problem is, I don't want it. I don't want the selected item, like, let's say I don't want a selected underlay to be above another kind of element, right? In fact, that does not seem to affect it. This does not seem to affect it. So editor selected, element style, Z index. So if I... Ugh. This looks like it's ignoring SVG Z index. How does Z index? Yeah, I don't think Z index works on SVGs. Okay, so I'm just gonna ignore this for now. Basically, the solution to this will be to either have the selection as a separate element on a different layer, which could be complicated, or just move the element within the thing, which could cause other issues. Ideally, what we would do is we would, while it's selected or hovered, we temporarily move it to the top of its stack, and then we return it when we're done with it, within its individual group. Because I'm thinking, if we want to create a selection hover, like a separate element to apply these filters to, we'd basically have to clone all the elements in the object. Which, especially for hover, could be a lot of objects happening very quickly. Then we would have to modify all their properties to remove any color fills and so on, before we can apply the filter. My nose is itching. 1 second. Well, we can move the underlays now. 1 sec. Just... Hey, the Asylum, if you want to stop by, let me know. All right. So that was actually pretty easy. And actually, hey, you know, why not? That's what object orientation is supposed to do for you. So let's go down our to-do list for first. First. All right, so this is a good test case because it's just so busy. So I want to drag a cage, right? So let's look at our cage component. We have a cage down, cage up, and we're gonna have cage move. Do we have the moves first usually? Yeah, don't know why. Do not change it now. All right. So cage down, move. So what do we want to do? If we're pressing it down and start moving immediately, if we're pressing down and we start moving, hey Andy, they are in different layers and it will be an issue. Again, the plan is step one is replicate the old CTC editor, right? So step one, there are no thermals. This editor is lines and these things, right? Rounded boxes, there are no thermals. Step two then will be to create sort of higher level components that just under the bonnet manipulate the other bits and pieces, right? To be honest, I'm cheating a bit with the killer cages because they're not really killer cages, they're just generic cages, which I'm currently limiting to these kinds of cages because I think in the CTC editor, there isn't really cage styling happening. Yeah, so they don't actually have styling on cages, which I will allow and add for my editor. But again, step one, replicate the functionality. So to grab the cage, I'm trying to think. If I'm holding it and then I start moving, so really, we want to do something similar to what we did for the overlay. So input down, we basically want to do a hit test. That's probably step one. So we do a hit test. Don't know if we need the cell size here. No, I don't think so. I don't think we need a cell size here either. Nope, it's not used. So we'll do a hit test. Right. Now the problem is there's no center, so we'll probably have to do an offset relative to, let's say, the first cell in the cage, for example. Should it have cells? If it doesn't have cells, the hit test will probably come back negative. So we have an RC. Let me get rid of this spam for a sec here. So, cage component, handle input down. Cage component, handle input down. RC, and then RC hit test. Why are we not seeing a match for hit test? False. How could it possibly be false? It wouldn't be... We wouldn't have a selection if it wasn't true. Hit cell, puzzle, math, floor, RC... Oh, fuck. DVD. So, RC. RC. Where's RC? I have an itch in my throat. A very mild itch, but it is a little annoying. There we go. Assignment to constant variable. All right. So we'll calculate a drag offset. And we'll use waypoints here, not cell. So this should be waypoints. No, what am I saying? Cells, right? Drag offset. Wait, what did I just delete? I think these are the full cell objects, right? Hey, motivation maxed out. That's a lot of smiley faces. You seem very motivated. All right, so click here, cells 0. Why is cell 0 why would that be an R? Is that a string or something? Oh, this is the R. Yeah, cells. We need not props. We need yeah. Okay. So we need cells from here. I think that should do the trick. Yeah, 4 cells. Okay. So drag offset then would be cells 0, excuse me, dot row, and then cells 0 dot call. We're just going to calculate the offset relative to the first cell. We just need some fixed point on the cage. And then the question is, how do we move the cage? Because right now the cage is kind of bound to the cells, so we kind of need to. And I'm almost tempted to change this highlighting as well, like make it red or something, so you know you've grabbed the. Or maybe we can change the cursor actually. Yeah, CSS cursor, 4 arrows. What's that cursor called? Crosshair, I think, or grab maybe. But yeah, that's for later. So we have a drag offset. Excuse me. And then what did we do in move? We checked if we had a drag offset. We did all that calculation again. I don't know if we used props. I don't think so. Props. Drag offset props. Okay. Props. Center. I think we're just gonna do. Don't need to get too complicated here. Let's forget up for a second here. Okay. Don't need props here. Well, that's how we get to know more stuff, learning. Trust me, I'm learning every day. I don't know half the stuff I'm doing either. All right, so we've got our cursor, our mouse positions. We have a drag offset, and thus we want to do a movement. Now, the movement is going to be a little tricky. Do I want to do it inside update props, or do I want to do all the movement calculation here? Because basically what I'm guessing I should do is to stay by my update props mechanic is to pass in a new cells value. And maybe even a new cage value. But that would mean parsing the cells and then like unparsing them and reparsing them. And it seems like something to do inside update props. So let's first calculate the next position. So that should be this, I think. And let's calculate that as well on the initial click, just for the sake of comparison to see that they match up. So here drag position should be the position of the upper left cell in the cage. So drag pause is, wait, drag offset, RC minus drag offset. Oh, wait a second. Hey, Sophie. What's your dissertation on? My girlfriend is currently working, figuring out the topic for her dissertation, and she's starting to panic a little. Come on, brain, work. So RC is a fractional value of row columns. Offset is the difference between that and the first cell. So let's output that as well for comparison's sake. All right. Put the props first. So what do we get? Cells is 7, 7. So the offset between this and this, that doesn't look right. RC 7.8, cell 0 dot row is, oh, negative 0.88. I thought this was 1.8 for some reason. Okay, but if we subtract the drag offset, no, we should add the drag offset. Why are we subtracting in the overlay movement? Drag offset. Shouldn't we, because the drag offset here is negative. Center minus RC, and then we do the reverse. Here we have cell minus RC, and then we have the reverse, RC minus drag offset. It's positive because the offset is negative. But here we're doing the reverse. This feels wrong. But that's what I want. I want the same position. Let's do the same math over here on the overlay component because something feels off. Ah, wait a second. Am I not outputting drag pause? Yeah, I am outputting drag pause. So drag pause is drag offset, and then so let's see if I take this 8.6. So the column gets larger. So this would be around 0, 0. I don't know what the center point should be the center here. This feels wrong. My girlfriend is, well, she's an architect, but she's gone back to university to do, my God, I should know it, Masters in Humanitarian Studies, I believe. So she's trying to think of a subject of her dissertation for kind of reconstruction after a disaster. Real-time rendering architecture and game engines. Fun stuff, fun stuff. Yeah, I'm building everything from scratch, but under the bonnet, the structure is very similar to how Unity 3D works, like with an inspector and components and things like that. And since I'm managing both the state of a visual element in the SVG as well as the data structure itself, I'm just abstracting all that stuff into little props, subproperty of the component. It's very common language in sort of editor internals. Okay, I'm gonna output all the other stuff here as well because I'm otherwise going to be too confused. We've got a center, and we've got a drag offset. So I grab this. We have an RC. We have a center, drag offset, and then we have a drag position. So far these are all adding up. What is strange is up here once we start moving. So as I'm moving over, the column is slowly getting bigger. So I can go, yeah. So how does this calculation and this calculation come to the same result? That doesn't make any sense. My brain is struggling here. So if I click this, the positive is the value. Is it that I am doing it wrong, and it's just because I'm grabbing it in the center, it kind of ended up roughly working out to the same, or it would round to the same thing, but it was actually wrong. So if I click here now, yeah, so it would have failed more likely on a larger object like this. My gosh, okay, that satisfies me. So I'm not going crazy just yet. Make sure I didn't delete something I needed. Yeah, that still works. All right. So now we know this is correct. I can now grab the cage, and as I move it, if drag offset. Wait. Here we go. Why didn't I do a single line on that here? Oh yeah. Probably should have done that ages ago. And here we do the same thing. There we go. And then here, drag offset comes out of the thing. Okay, so I can grab this, I can move it, and I get the update into formation. The only problem is... yeah, okay, no, that's not a problem. So now we have to translate our position accordingly. All right. I think since we're in the cage land, we know that we can round this to the nearest whatever, right? So we first gonna parse the cells, and I'm not gonna build that code here. So parse cells. Puzzle. And we grab this from props. So that's props.cells. So grab this, no, wrong object. Grab this, and it gets us the actual cells. Which I don't really need here. I really kind of just want the row column values. So now we got to map those. Each cell has a row and column property, and we want to map those to offsets. Now, yeah, I mean, we could No, we want to round them. We want to round them here. Round them or floor them? Round them, I believe. No. We want to convert... We want to... no, it's relative to the... Yeah, okay. It's relative to the upper left corner of each cell, so we can just... there's no shift from center to corner or whatever. So we can just round them. So we're returning math.round row plus drag and wait, it's all relative to cell 01. Okay, one second. So we have props, drag offset, we have cells. So we need to subtract cells 0 here. 1 second, Toby just came home. 1 second, guys. Gotta say hi to the dude. All right. He knows when I'm streaming, he doesn't get any attention, so he's just plopped into his bed with a sulk. All right, what was I doing? Yeah, so I'm realizing everything needs to be relative to the first cell. So we have an offset relative to the first cell. We're calculating the new position of the first cell, but since we're applying it to all cells, we're actually going to subtract the position of the first cell. So our new drag position should now be relative to the origin of the puzzle, basically. Whoop. Except it breaks. These are cells. So that should work. All right. So that's relative to origin. And now we're going to go through. Do we need to parse them at this point? Probably not. Yeah, we don't actually need to parse the string here because we know that the cells area contains the cells, right? So we're just gonna map the cells directly, and we can just add drag pause here for row and column. Nope. Do we have enough brackets? Enough braces? Looks like it. So that should give us updated positions for all the cells. Now the question is, do we want to process those back into our cells array? into cells array, cells property. So it'll be that. How does that conversion go the other way around? We're already doing it when we're adding and removing cells, so I can just look at that code. Cells.push cell update path. Okay, so this is based on the cells array. Do we want to update the path? Because we have two options, right? We can try to just shift the whole object, but I think the whole object is doesn't actually have an XY coordinate, or does it? I don't know if the path for these things is actually position XY or just positioned relative to the origin of the SVG. So let's do grids. Yeah, give me one of these cages. Here we go. So this path, it probably does not have an, yeah, it does not have an XY coordinate. That means the path data itself is relative to the origin, which is probably not what I should be doing, but it also means I can just do this and it will update correctly. What it won't do is it won't check if an update is required. So I think instead of doing this, we can just directly update the cells and then pass them through. This update path looks at cells. So it regenerates props.cells. So this just dumbly regenerates the path. Now, since it doesn't happen very often, I think that's okay. So let refresh path equals false. So we're just gonna do it one by one here. I was tempted to run it through update props, and I probably should, and I might later, but I think this is actually going to be a lot faster. So what I'm actually going to do here is cells dot for each. The funny thing is we're not actually moving the cells. We need new cells, right? Hey, Saralash. Yeah, I already have it for these elements and for the lines. Well, I have it for the line points, but I want to add it for the whole line, and now I'm adding it for the cages right now. Just for completeness sake. So here, what we really want to do is we want to go through the cells. We want to check if the cell position is different. So let a new pos equals, or let next to be consistent. We take the row of the cell, add the drag position, and do it the same for the column. All right. And then we'll just check if they're updated. Now, if they're updated, we actually need to replace this whole cell object, which might be a little bit trickier because I think update path doesn't do that. So if next pos is different, then we probably need to update this object here. So if next pos 0 is not equal to row, or next pos 1 is not. Actually, you know what? We could do it even easier. We can just use get cell, right? So we can just retrieve that. Oh man, I'm deep in deprecation land here. So much code I need to get rid of. Where was I? Here we go. We can do let next cell equals puzzle get grid, and then we'll just get the cell at that position. It's a little, it's actually not very, that's not an expensive operation. We don't need that anymore. And then we can say here we got cell. Let row call the cell. Then we can say if cell is not equal next cell, we can do refresh path equals true. Now we can find out if I do this, refresh path false, false true. All right. Now, obviously, we probably want to not let the path push outside, right? So we probably want to say if next cell is not undefined, in fact, we have a problem here, right? Because if it's undefined, we have a separate condition here. Refresh path. Trying to think. We could let you move the path outside and then have the cells being removed. Doesn't make a lot of sense, no. Invalid cells equals false. If cell is undefined, it's nope. Right. So invalid cell is false, refresh path is true. Here refresh path is false. True, true, false, false, true, false. Okay, so if this is true, false, then we want to update. So if refresh path and invalid cell and not invalid cell, then we want to refresh the path. But we have to be a little bit careful because now obviously our data is invalid, so we need to update the dragging position as well. Oop. Okay, 1 second. Let's stop this as well. All right, what's going on here? So, actually, let's log out the fact that we're updating the path as well, so we know we're hitting this. Oh, because we haven't actually updated anything, right? We haven't updated the value of the cells array. So if we're refreshing path, if refresh path is true, because I was saying, we could just update the cell here, but in reality, we'd have to undo it down here again, which is a bit silly. So what we can do is let next cells equals array. Because next cells idx equals. The next cells now should be a list of new cells, and if this works out, we basically want to splice next cells into that. So we want cells.splice at position 0, cells.length, splice apply. This, right? I think we've done that before. Here we go. You did that? All right. And it won't let us push it outside. And does the... I'm not updating. I'm just worrying because the drag offset was calculated relative to the cell, the top left cell of the thing. We're not updating it. Because it's the offset, right? The offset shouldn't change. Yeah, exactly. Okay, so that's fine. So let's see if that works with weirder cages. Now, what this doesn't stop is overlapping. So, I want to rotate this now. It doesn't let you play Tetris, because it does let you overlap, which might be almost like a hacky way of letting users... Oh, that's a problem. It won't... It's relying on the RC hit test. No, wait a second. Why is the dragging not happening when I'm leaving the confines of that? 1 second. Because I could drag the cursor out of the cage, and then it won't let me drag anymore. So we have a move event, but what's going on here? That's not quite working. Let's see. We have a drag offset. Oh, I'm an idiot. I'm an idiot because I'm trying to move it up and it's pushing against... I just made it so you couldn't push it against... Yeah, and if I delete these, this one, now I can move it there. Okay, all right, cool. So that works. And I think, yeah, because it's on such a rough grid, rebuilding the path object is not a big deal. It's not going to happen very often. I mean, it'll happen as you're like... This is probably going to make the CPU spike a little bit, as we saw earlier, because manipulating the DOM can be expensive. So if I take this, right, 7.7, but if I move it quickly, yeah, 28, because we're thwacking the DOM and adding and removing that element all the time. All right, so now we need to clean up the stuff that happens around this. Because right now I think when I put it down, yeah, it removes a cell. So, basically, yeah, so it's not the existence of drag offset, it's have we moved the thing? Because if we haven't dragged it, then we want to do the regular stuff, right? So if this drag offset, yada, 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 if refresh path, this has dragged, was dragged equals true. So when we set the drag offset, yeah, so we don't need that anymore. Don't need that anymore, and we can say this dot was dragged equals false. And then here we can say if we had just been dragged, we don't actually want to do any cell manipulation. We do want to update the inspector though, but that's a separate story. So we want to delete the drag offset. We don't want to delete, the heck was that? We want to delete was dragged, and we basically want to return. Yeah. Ooh. Ooh. That's bad. Ooh. What just happened there? Update path 13 times. Down, handle input up. This dot drag offset. Oh. Yeah. This should always be deleted no matter what. Alright. So if I move it and release, no delete. If I do this and release, I'm thinking that there should be a timeout. So if you press down and you wait more than a certain amount, there shouldn't be a input up. So let me think. There's two things we can do. Is we can calculate the minimum movement, which only sort of works. We could do something in input move. So if input move triggers, we'll set a flag, and the moment input move has triggered, we're disabling this stuff. Things you don't want it to be too sensitive, right? So you don't want to have it to be pixel accurate, right? So you need a kind of a minimum thing. So we could do something else. I'm thinking, can I use drag pause to see how far we've moved, and then say, okay, if drag pause is larger than a certain amount, then we'll set was dragged. We don't actually care if the cage moved. Okay. We have distance here, right? Distance. So if I say distance, if I do this, and then we'll do distance, drag pause 0, drag pause 1, and then we could check that against our, so okay, so that's distance in cell units. It's like, ooh. So, mouse handler. Wow, this is so laggy. The latest update to Sublime, I really don't like it. Did input move? I think that's the one that checks against double input distance, which is 6. I think that's screen space coordinates, which would be a little tricky for me to actually I think half our cell division's length should do the trick, right? So our cell divisions, if we're looking at a line, we're looking at a line. So we're dividing the whole thing into 4 quadrants, right? I think that makes sense. And since we're in cell space, not in cell unit space, I need to come up with names for these things. We should be able to say something like, if drag, let's do this. Let drag dist equals, if drag dist is less than 1 divided by cell divs, oops. Sol.born moved. So that should let us figure out if we've indeed moved the mouse or not. Or if we moved it sufficiently, right? So if I move it that far, but if I move it from here, oh, I move it like this, greater. Yeah, greater equal. I think it should be half of that, actually. Yeah, it should be half of that. So, 0.5 divided by that. And then if we have moved, that's when this is dot dragged will become true. Right. So now I should be able to do this and click, and we should be able to look at was dragged here. And get something useful. Although just now it didn't work. Hey there, Asylum, thanks for stopping by. I'm just homogenizing all the drag and drop stuff. So was dragged is true. Now if I do this, was dragged is false, okay. So I can do this. Okay, I can still do this. But I can also now say, oh, okay. But yeah, editing like in a busy puzzle like that might actually be tricky. So I need to think of something for that. But if the drag and dropping, for example, is super smooth, then it could be as simple as say, hey, move it into a less busy corner and then move it back after you made the changes. So maybe that's the solution, you know, make other things so easy that then the real tricky stuff isn't that tricky. Now this is all getting kind of complex, and I'm hoping that maybe I can create some sort of subcomponent that can handle drag and drop across all the elements. But they all need a little different handling of how they're updated, how their reference coordinates are calculated, and so on. Now the line is the last kind of complex thing, because the arrows work the same way as the line. So we kind of want to do the same thing with the line. Now with the line, it's a bit complicated because we already have a bunch of timed triggers and all this stuff. So for example, here we're first already calculating all this stuff. So we're getting the closest point. First event RC hit the closest position on path. So on input down, let me think. So I have a line selected. On input down, what's the first thing I want to check? I think I want to do a similar thing like to this. So the problem is, yeah, okay, so I need to figure out what exactly my mechanics are. Right now, press and hold, and then release doesn't do anything. What was it? Ah, okay. Press and hold on a dot gives us the confirmation to delete. So maybe we don't even need the confirmation if the hold is long enough. Ultimately, everything will be made better if I can get undo to work, because then I can have slightly less fiddly controls, or more fiddly controls that go wrong occasionally if the undo is super easy. I think that's how a lot of people operate in editing tools. So what I'm thinking right now is that we just have a hold timer. And we have two of them. We have a delete one, and we don't have a confirm click. So if I'm holding on a point, it deletes. If I'm holding on the line without a point, it adds a point. And if I'm dragging before the hold kicks in, then we're moving the line, right? So there's a bunch of code for each of these things. So let's think about this first. For the dragging, we want to do an RC hit test. Right. And we want to modernize some of this code because it's using some old stuff. We have normalized RC, for example. So we can do this. Then we have path from props. Okay. So I'm trying to think, okay, what's the first thing I care about? So we're getting selected. Boom. I need to clean that out as well. So it ignores the long press here. And it does it with a timeout, I think. Ah, no, it does it with the first event check, right? All right. I think what I'm going to have to do is, first, I'm going to have to disable all the other stuff as much as it hurts. Disable all the stuff. I think the timeouts I can manage differently now. And same for the input movement here. I think return true here isn't relevant. No, it's not. Okay. So, boom, boom. Okay. And now the first step is we'll check if we have a hit. I mean, right now I'm just going to output a bunch of data to kind of get my head around what I have available, right? So we have a hit. If we have a hit, we can do a line split, for example. Let's do the line split first, right? So I press here, RC hit is true. We're on down. So if I start moving, so let's do this. If I start moving, we need to know our offset, right? So we should calculate an offset here. Okay, so the offset we would do relative to the first waypoint. So we'll do it similar to what we did with the cells in the cage. That's the overlay. So in the cage, we had a bunch of cells and we calculated our offset relative to the first cage. And I think this return true is not required on these because it happens in the parent. And we only do this on the RC hit test, right? So props, and then we'll do the whole, well, we can actually just do this and this, this, and right, so let points equals props dot waypoints. And I guess it makes sense to only drag if you're within the hitbox, selected or no selected. Boom. All right. So then we'll take the first point and we can calculate our drag offset. And in this case, yes, it's an array. So many different coordinate systems. Each one is slightly different. Because, yeah, if it's easy, anybody could do it, right? So drag offset. Boom. And that's relative to this point up here. Now to move the line, we probably should do an update path function here as well. Make it a bit easier. Because we need to move the handles as well and such things. Okay. So the next step is handling the movement. Again, it's similar to what we did for the cages, so we'll look at that code. And in fact, by looking, I mean we're just going to copy the whole thing over and then modify it until it does what we need it to do. Right. So we have a drag offset. We don't have cells now. And we're gonna calculate. We're going to calculate. We're going to calculate things like these. And we can probably do the same thing with drag dist and all that stuff. Right. No, this we don't need here. Now we care about the drag position. So grab it as we're moving. Is this updating smoothly? Sec. Drag offset. The drag position should be 0, 0 at this point. The drag position should be 0, 0 at this point. So let's output it here and confirm that. Drag position. How does it come to a positive number over here? 0, 0, 0, 1, 1, 1. 0, 0, 0, 1. Because I'm missing a chunk here. And delete this dot drag offset. I think that should stop the dragging. And go back, and it should go back to 0, negative, up, down, and right, and up, and then back to here, and we could get back to 0. Okay, so that gets us the correct drag position. So then we probably want to do a similar shenanigans. Yeah, we probably want to do the same sort of shenanigans about marking if things were dragged or not. Man, I need to encapsulate that into a singular, reusable little sht. There's so many repeated elements. It bugs me that I'm writing and cutting and pasting so much code. I'm almost thinking the component itself could handle some of this dragging. Like for example, right? The thing is, this is already, you know, this is like, we could do like a start drag. It does the hit test check. So that's the same. This is different, and then that stuff is the same. So we could encapsulate this into a drag start thing, and this would give us the reference position. Now we could do it in two different ways. We could pass the reference position in, or we could have a function that returns a reference position. And then update props could literally just have a move special property and just magically use it. And each element has to implement how to move itself. And then all the timing could be handled in the drag and drop higher level mechanisms. Let me have a look at these low level functions here. In fact, there aren't any. Oh, let me think. How trivial would that be? Get ref position. I mean, the API will get huge. But my brain likes the idea of having sort of a homogeneous sort of drag and drop mechanism. Let me think. Let me see how that would look. So we'd have to do a get ref pos. And that just would return, you know, turn 0, 0. Then we would have a start drag. And that's basically, let me just do this. So something along these lines. then this dot prototype dot name, no event, start drag, and we probably do like a something for the grid ref pos here as well. So let ref pos equals this dot get ref pos, and that should just create an array, a 0, 1 array. And we're just going to assume if hit test can pass, then ref pos will pass. So let's implement this. Where are we here? Cage. So p dot get ref pos. And that should return an array of these Solomon things. Right. And then here, we should be able to just call, in fact, we won't need any of this stuff. We'll just call this dot start drag. Makes sense? And this was the cage. Undefined reading name. This dot prototype. This dot constructor. So if I click on the cage now, it executes start drag. But, yes, component cage component. Yeah, that's what I was hoping. It does all of this. And, oh, yeah, it still works because it's replicating this thing, right? So, now, the question is, will it struggle to interact with things like the node editing in the line component? We'll find out. We'll find out. So start drag, or drag start, let's do it, drag start. Prefix the thing, and then suffix yada yada. So this would be drag start, and we'll have drag move. And then similar to this, we're just gonna call this dot drag move. I don't think we're doing anything else here. Now the tricky bit here will be to extrapolate what's unique to cages and what's generic. And if we can reuse things like the get ref pos and all that stuff. So, this won't matter. Props won't help us here because we won't know which props this particular component has. We have RC. Then we want to calculate the drag position. We can do this relative to the ref position again. Yeah. So drag offset. It's a one-liner. So that gets us how much we're dragging by. Then we do the whole drag distance thing. Now the drag distance is for the was dragged. Okay, so that makes sense. That makes sense. And was dragged. So far we're still in generic land. Well, drag distance was dragged is true. Great. Now, what we do not know how to do is how to move the object. And we have no thing for the rounding and all that stuff. So that's basically everything happening in these lines. So we need a dot move component function. And we'll have a delta, right? Move delta. So we have move component, move delta, move delta, and then we want drag distance, drag position. So drag position. Wait, what is drag position? Is drag position the new position or the amount we've dragged it by? If we go back to 0, 0, it's 0, 0. Yeah, so drag position is actually drag delta. Delta. Right. So then we can do this dot move component, drag delta, and then we can overload move component here. Are we in the right place? Yeah. And cage component, cage move delta. So we're executing this code. And now we can do all of this. So refresh false, invalid cells, yada, yada, yada. So we need to get some references here. Don't think we need drag offset anymore. Don't know if we need props, probably not. And then console.log. And I'll put this. Right, and we probably want to output next cells. I don't see why that wouldn't work now. Oh, puzzle is not defined. Puzzle, 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 puzzle. Puzzle, 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 puzzle. Here we go. Oh, come on. I do not want to double magic edit. I just want to frickin' paste where I'm pasting. Jeez. All right. So grab this, move it, drag pause is not defined. Drag pause. Next cells, drag pause. Move delta. New name. Always new names all the time. No consistency ever. Consistency is not allowed. Okay, and then we really, whoops, we really just need to run these two lines, and that should be it, right? Nope. Sweet. So get rid of that. Is it simpler than what we had before? Arguably. Arguably. I mean, all of this disappears, right? The real sweet stuff happens when we can see how it interacts with other things I want to do, right? So now we'll have drag start, drag move, and then we'll have drag end, or drag stop. Drag. Why do my brain wants to say start and end. It's just how it works. I don't know why. So delete this drag offset. If this was dragged, delete this was dragged. This is the problem, right? Because we need to know if this was dragged. So we kind of want to do this, right? And then here we want to do, instead of these 4 lines, we want to do if this drag stop return. Right? So now I should be able to click delete or drag to drag. Yeah, okay. So that actually worked pretty well. Don't mind this at all. So let's port the overlay elements over. So I think currently the overlay elements don't do anything besides the drag drop. Okay. So ref position. So here the ref position comes from center. Props. Or props center. So I'm just going to do this. And then we should be able to just execute drag start, etc. So input down should become drag start. And then drag move. This doesn't look right. All right, drag move. Should become drag move. And yes, I'm inconsistent because here I put move above, up, down, and then up there I did down, move, up. So to be consistent, I probably should do this, even though the other order actually makes more sense. So move component kicks in, but of course we don't actually have a move component implementation here. And move component here should operate like this code. Move component. Am I in the right place? Overlay component. Yeah, we don't want all of this here. And we want to move things by move delta. So we don't actually need to do any of these checks. And it's just plus move delta. Like that. Sweet. So that just breaks. Center here should be relative to our ref pos, right? So we should be able to use that. No, we don't even need. We just need relative to itself. So so it'll be center plus move delta, like that. I think. Grab it, move it around, drop it. Grab it, move it around, drop it. Grab, move around, drop it. Still interact with it. Sweet. Okay. So these just work now. So far, we haven't implemented any timing stuff yet. So that means we can we delete all of this? I think so. And then here we'll just call drag stop with the return. I'm just going to do that so in case we're adding some functionality there in the future, it doesn't get weird on us. All right. Now, we might be able to wrap these up as well, but I'm not going to worry about that right now. Okay. And then cage component has update path being logged out and move component. All right, update path. Okay. All right. So finally, we want to update the line as well to use drag and drop magic. So first of all, I'm going to move this down to Electric Avenue, to the cage component, I think. Because that's the most similar in functionality to the line component. So step 1, implement get ref position. And here, it's based on the waypoints. And then we're just going to return waypoints 0. Spread out all over this area. Okay. Yep, that should do the trick. Then we want to implement the move delta. By implement, I mean stub it. Don't implement anything. Just stub. And for now... Oh, and I can't delete that because that is actually the implementation of the line editing, which... Yeah, okay, this is where we left off. We haven't actually... Line dragging never worked, right? So this is all new. So this would be drag start. And we're just going to sneak that in the top. And then on move. Jeez. Just gonna turn. So this is drag move. And then we have drag stop on up. So instead of doing this, we're gonna do this. And yeah, move component isn't implemented, so it does call move component. So handle input move. How did we do the moving? I keep saying it. No, we haven't done the moving yet. There is no moving. Okay. So we know our move delta. And this is cells. Why is there cells code here? Because I haven't implemented it yet. God damn it. How many more times is this going to happen? So this is just cut and paste from the cages. This we've just replaced with shared code. Okay. So what we care about is this part down here. Waypoints. Update props waypoints. So we're going to do it similarly to the cage component. Move component. So we're basically... it's a bit different though, because lines can go outside the grid. All right. Point handles for each. Drag point, update, drag point splice, drag point length, get raw, RC, get raw RC pause. Yeah, but that's for 1 point. Ah, because we're not dragging a point at all. We have a drag. Yeah, we're just dragging the whole thing. All right, all right, all right, all right. So, where are we here? We're in the cage component. So here, we're going to do let waypoints plus this dot props. So we're moving waypoints. Oh, and we probably want to output the move delta as well. So if I grab this line and drag, we have a move component, we have a move delta, and we have an area of points, of waypoints. So what we really want to do now is update props with these updated, but we need rounded stuff, right? Rounded stuff. Let next path equals. So we're gonna take the waypoints, we map them. We have RC pairs, and then we're going to add our move delta and then round it to our drawing whatever, right? So this will be R plus move delta 0, C plus move delta 1. That gets returned, and that gets us the next path. Right, indent these. So grab the line, drag. So if I compare this with this, it's offset. The move delta is positive on the column. R, move delta 0, move delta 1. The move delta is relative to the original position. Is this a problem here? It wasn't a problem with... Yeah, no, it's relative, so it shouldn't be a problem. But these numbers do not look right. Can just do this, I think. That should roll out the area a little bit. So R is 0.4. So this doesn't make any sense. What the heck? Move delta 0.05. R plus move delta is get draw RC. Oh wait, get draw RC is do. That's we want to draw RC, not get draw RC. So that should make more sense. Because get draw RC is in board coordinates, not in cell coordinates. Yeah. So we moved it over, it went from 1.4, and we jiggled it a little bit, so it went up and down a little bit. Okay. So now if we do this, will that just update the whole thing? Because I think that's exactly what it's supposed to do, right? Yep. There we go. We can move it off screen. And we can put it back. Yeah, that's it. That's what we wanted. Now we want move delta to be smart enough to, if I do this, yeah, so it's getting set to dirty properly. Okay. And its update, I guess update props here is smart enough to check if the line actually moved. Well, actually, in this case, it's not that bad because we're not generating or destroying objects and all that stuff. Cool. Okay. So that's step one. Let's reduce the spam. Step one being, you know, we can now drag and drop lines, but we can no longer edit them, which kind of sucks, right? So we don't have hover on the points now. let me think. So step one is, so drag move doesn't do anything in this case. So we should be able to just continue executing the rest of this stuff here as before. Yeah, and we probably want to reduce the spam here. Now, the whole drag point thing, that's the other thing now. Can I reuse our drag API for moving a singular point? I almost want to treat the point like a sub-component, which kind of makes sense almost. Like, imagine each point was a component. It's tempting to try to hijack the mechanism, but it's not really designed for that. All right, so before we're doing dragging of points, let's try the whole hold to split part. So drag start. If was moved kicks in, we don't want to do that. Hey Mark, how are you doing? So I've kind of created a higher levels generic drag and drop mechanism that I'm reusing for all the components. Hurrah! But in the meantime, I've destroyed how the line editing works, which is of course the most complex mouse editor I have currently. So dragging happens here. Let's write down what we're going to do so the thinking becomes a little easier. Step one, if if long press and not move, comma, insert point. So that's adding a point. If long press on point, if long press on line and not move, and not move, delete point. And 3, if press point and move point. That's basically the 3 things we want to do, right? So step 1 is we're pressing down. If we are on the line, we start a timer. If at the end of the timer was moved, or whatever our marker for drag and drop is still false. Let's check what our marker is. No, this is cell. Drag move. Move component, drag delta, was dragged. So if was dragged is true, if this was dragged, this doesn't move component. If drag is greater than half a cell division. There are some assumptions here which we have to be careful about, because there might be components that are lower resolution. Yeah. So let's have a look at this. Let's output these things, right? So we're putting the mouse down. Was dragged true at this point? Secondly, are we hit testing? Do you think of how, or if you want to be able to change the latency in it? I want to. The problem is right now, the CTC system is very kind of structured on where things go. And FPuzzle is actually pretty structured too. There's a certain order to things. Like, it doesn't make sense to put the value of a cage underneath a background color of a cell, for example. So it's kind of hard to justify arbitrary Z-order indexing when it's really just introducing more works to the setter. Now, the way the CTC editor, I think, philosophically handles it is that it has an arbitrary overlay and arbitrary underlay cage. One of the problems I've encountered a long time ago already is that how to handle transparency in colors, because you never want to completely cover up things, right? That's why my colors are always a little off, because they're always slightly semi-transparent and all this stuff. But for example, the underlay color should be it should be safe to make it opaque. But it should also be understood that multiple underlays do not overlap, which they totally could. The other thing is that FPuzzles, for example, doesn't have such thing as an arbitrary underlay. It has a cell background color, which the CTC editor doesn't actually have. These are just arbitrary rectangles that just happen 99% of the time to be exactly one cell large within one cell, right? Even if they span multiple cells, those are usually added as multiple individual underlays, because it's easy to just click and add because it remembers the previous setting. So it's a little dicey while I'm sort of floating between multiple implementations. Again, first I'm going to replicate the CTC editor capabilities, because that's what my engine is based on, and that's what FPuzzles translates into. And it's basically more powerful than FPuzzles in terms of rendering the puzzle, right? It has zero concept of constraints, obviously. So you know, there's nothing there. So by implementing an editor for that, it just means every puzzle in my that can be loaded into my player can also be edited with this editor. That's all it means. And it's relatively easy for me to make it slightly more powerful, because there's certain things like cage styles. There's certain things like little add-ons that I would like to add. And especially relative to the CTC editor, there's a bunch of automatic stuff I want to do. You know, I want to have predefined styles. So if you have a line, you can choose to style it as a whisper line, and it's just a preset for color and thickness, right? Stuff like that. So I can obviously have my own little extensions to the CTC editor. But, you know, we'll burn that bridge when we get to it. So if I click here, I haven't updated yet. All right, so if I click here, RC not defined. Yes, because why would it be? I've just delegated all of that to the drag start thingamajig. Man, I'm recalculating this position so many times, it should just be available somewhere. Okay. App is not defined. Well, I'll be damned. Sure. All right, copy all the code. So was dragged is false, RC hit test is true. So what did we say? Now long press, how do I implement that? So there's a couple of ways of implementing it. I can set a timeout and clear the timeout and do all that managing. I can, in this case I need a timeout because I want it to just happen. I could say, hey, if you release and you had pressed longer than X, then I can just mark the time when you press down, and then I can just measure it at that point. But in this case, I think I'll do a timeout. So let's just do this here. Let split timeout ID equals set timeout. I'll do const split let split timeout equals 500 750. I think it's fair. I don't know. Half a second sounds like such a short time, but when you're pressing down and you're waiting for that half second to pass, I need an animated cursor, right? I need like a cursor that fills up, like a little circular thing that goes as you're pressing it down. Make it a mini game, right? Oh my god, I might actually implement that. All right, set timeout, yada yada yada. I'll call that MS so I don't get confused later. Well, I'm not putting any work into Z ordering right now. Oh, because you were... No, that was, to be honest, that's mostly the highlights. So, for example, if I have a puzzle like this, you see the highlights are underneath the other elements. It just looks a bit ugly. So I wasn't actually suggesting to implement Z editing. It's more like I need to rearrange the Z ordering to make the highlights work correctly. And I might do it by moving this to the top of its respective layer rather than, you know, or I could have, you know, I have my editor handles layer. I could move the currently selected element to that, but then you wouldn't want the underlay to jump on top of everything, right? So it was literally just about the selection and highlighting Chrome, basically. All right. So if I click here, rc hit test timeout console.log split timeout. So we click here. Yeah. And I want to collapse all of this. My god, I have to move all the way down here. Right. If this drag stop return. No. Clear timeout. This dot split timeout ID. Yeah, we don't need that. And stuff like this I'd like to encapsulate as well into some sort of mini component. So if I do this 1, 2 and release, no timeout. Okay. So at the split timeout, we want to see if things have moved, if things was dragged. False. If I move it, was dragged true. Right. I'm just going to rely that distance is enough. It might be too much and I might have to change that and add a lot. It sucks because I've implemented a lot of this stuff already in the app itself. But I don't have a good API to hook into all of that at the moment. So it's not easy to reuse that code for now. Anyway, this is enough. So if the timeout expires and we haven't been dragged, we want to do the split, right? And the split operates by cell point stroke. So that's the delete timeout. I believe it's this guy. So this little ditty of code, and we don't care about the first event here. So if this was dragged, return. Fine. No splitsies, right? Otherwise, new P, closest point on path. All right, we got a bunch of stuff here. So we should have this. And we should be able to compare that to path, which isn't a path, it is waypoints, right? Sure. After argument list. That way. So clear. Nope. And that path has one more, right? And if I just move it, let's drag just true. And if I it's just long enough that if I click on it, I can click on it quite safely without triggering it. So this might actually already work. Let's see. I mean, I'd love to do more visual stuff, but it takes so much time. I mean, after I release it, maybe, you know, I'd love to do like a little animation, get our scissors flying across, cutting your line in half, you know, that kind of thing. So that doesn't do anything. If I do this, I now have a new point. It would be cool if I could immediately drag that point as well. There's something happening though here, as if 2 point handles got added. And in fact, it looks like 2 points were added. Is there something I can do to mark that this split has happened? All right. So we have all of this. How about we'll put that into a function. Insert point at RC. And then we'll do all this stuff. RC, waypoints to draw, yada yada yada, next path, insert point at, insert point at, RC, RC, and then instead of all this junk, we have a little function, this dot insert point at RC. Is that enough? Might be missing something. Okay, that seems to work. So that's number 1 on our list here. Number 1 here. So number 2, if long press on point and not move, delete point. Okay. So this thing presupposes we are not on a point. Okay. Set cell point, closest point on path. Closest point on path. Okay. So I think we want to do that first, actually. So we'll call this 2. Then call this 1. Because I think we first need to see, hey, are we on a point, right? I can do that path, and we'll encapsulate that into a function later on as well. Path, closest index. Okay. And then we'll do a similar thing to what we did below, but for a point. Closest index here we probably don't even care about at this stage. Can run properties undefined. Path, waypoint, insert point at path. This should have an S at the end, right? Yeah. So down, input down, RC hit test true, was drag true, closest point. Now, if I select next to it, I think I want to be within the selection of the line. So even though, yeah, we probably need the distance here. So what do we do with this? Drag point. This is the drag point. This is down. Equals closest point, select point timeout, splice. This drag point. Where's drag point assigned? Here. Okay, this is, I think, our margin. Yeah, so we don't actually need that stuff here. Let's just write the code that we need, nothing else. So this is our closest point. So at this point, we're pressing down. This should never happen, right? So let's call this a drag point. Or a selected point, drag point, edit point, selected point. Right. So at this stage, if we have a selected point and we are in down, if there's a selected point, this should never be possible. So if cell point return. So if I go here, cell point is true. If I go here, eventually it does this. One thing I don't like is that then I have to... No, well, maybe we can... After we've split, we might be able to move the point. So we don't... You can press down, hold it until it splits, and then drag, and then release to place the point. I think that would be a nice interaction. So let's see if we can do that. Might be possible, right? So we have a selected point. Now we have to do the same timeout shenanigans here. Basically. And I wish there was a way of cleaning this up. And man, I'm Mr. Systems and Frameworks, I tell you. All right, let's do the same thing. And in fact, instead of these timeouts, because there should only be one at a time, right? I almost wonder if we should have like an interaction timeout or something. Because it doesn't matter which one we're doing here, there's only one. And all we want to do is pass in a function, a callback, basically. Let me think. Number 3, press point and move point. That happens here as well, right? Just without the timeout. So this should be 2, actually. And then that would be 3. Okay, we have a selected point. If we wait too long, we'll delete it. If we move it, we'll move it. And if we release... Okay, so step 1 is... Step 1... And I just had a silly idea. We can animate this. Ugh. I'm gonna do something really terrible here now. So this was stroke weight 8 and red. This was our deletion highlight, right? Then our hover highlight is actually done... Wait. What is doing that? Wait a second. Oh, it's in move. Okay. So it's doing this stuff here. So if I go here and press, we're deleting it, right? So what if we do something like this? Set interval. And here we're gonna do let del interval ID equals set interval 30 FPS, 30 milliseconds, 20 FPS enough? Do we want to do it more often than 20 FPS? So let's do a quick test. You'll see what I want when I'm trying to get my head around here. Set timeout. We're gonna run the animation for 1 second, just for testing. And we'll do clear interval this. And we're gonna run it at 10 FPS. I'm gonna give you a hint. I'm gonna fix the spelling. Here we go. So if I go here now, shrink times 10. Okay. So I'm gonna disable this for a sec. So we're gonna handle this in a slightly different way now. So we know what our point is. So we can do cell point idx equals points dot index of cell point. Right? That should give us an index that we can use. Points not defined. Path. All right. Cell points is 0.2. So we should be able to get a handle on it. Get it, handle on it. Excuse me, my nose is itching. Don't really need to blow my nose, just scratch it. So, point handles. Let's get a reference on point handles. So we can do that in here. That, yada, yada, yada. This is all encapsulatable. pH equals point handles. This, we don't actually need the index, right? And then we'll start with whatever. What's the default size? The default size is 0.3. So p dot update point handle function attributes and we'll give it what, an index or the handle itself? We'll give it an index. Right. IDX. So, size equals 0.3 or progress equals 0. And then here, progress, whatever. Progress. We're going to change this to progress. Plus equals. So we have 10 units. We want to get to 1. We're incrementing by 0.1. I think so far we're still in business. Well, right. And then we want to do this.update point handle idx attrib. Oop. Yeah. Radius 0.3 minus times 1 minus progress. We want to do that in reverse, right? And then we can do this. Gonna be a little spammy, but it only hits 10 times, so it's okay. And hold it down, radius goes up. Progress goes from 0 to 1, from 1 to 0. Oh, it goes towards 0, sure. And then we can do object.keys attribute. Actually, what is it? Object.values? Object, no, not values. Entries, right? I think that turns it into a array of two element arrays. So each of these should be radius yada yada. Okay. So then we can do something like this. Dot for each key val. And we can do a switch on key. Case radius. I'm trying to think how I'm going to do this best. Probably actually what we want to do is radius equals at... Can we do it the other way around? Let radius equals 0.2 equal... sorry, that's the default, equal at, like that. And we'll save this for later. But what we really want to do is let d equal let r equal radius times svg renderer dot cell size, and that's not how you spell that. That's how you spell that. And then d is gonna be this. All right, and we need path. So let path equals this dot props dot waypoints. I just do this. Be done with it. Like that. A singular thing. Okay. So we have a D now. And then we can do point handles. Where are we resolving all this? Here. So we can do point handles. We can do let ph equals point handles idx, and we'll do that higher up. Here. And then we can do ph.set attribute d. But attr not defined here. Look. So we probably then want to give it a bit of a radius and maybe change. We probably want to set the stroke width to something larger, and then stroke. Like basically I want to emulate its sort of disappearing, right? Okay. But the moment I stop, I want it to be reset. So so that's this dot del interval ID, and we're gonna do the same. Oh, Jesus Christ! All the way down here. Did I? No, I didn't copy it. Of course, I didn't copy it. After scrolling all this way, why would I actually copy it? Let me see if I can collapse all this. Don't know why all this is separate. That's painful. All right, the delete interval ID. I need to homogenize, combine, reduce, eliminate. Hate code. Gotta remove it. Okay, stroke width is 3. Because we could reduce everything, right? We just scale the whole thing down. And then if the splitting animation, if the split doesn't happen in the end, then we have to reset, right? Ooh, unexpected string. Whoop. Whoop. Plop. Okay. So we basically want to do this. And we want to go through all of these. Maybe we want to do these first or after. For each key val, we basically want to do this here. Val, key. Right. And if I do this, now the moment I stop, I want it to reset. But not exactly. Okay, we'll get to that in a minute. But that could be easily our indicator for deleting the point, right? We shrink the point, and when we hit 0, that's when 20 FPS, maybe less. Yeah, 20 FPS is fine for this silly thing. All right. And then if we hit 0, basically, if we hit this, right? Ah, no. Oh, this is all such a... How would I encapsulate this? I want something that progresses over a set interval, has a ending time. I mean, this is basically the core of animations, right? But can be aborted earlier. And then just has callbacks for all this stuff. I'm not going to implement it right now, but I'll probably implement it later. So I don't have all these separate IDs and all that. You know what? Screw it. I'm implementing it now. I'm doing it right now. Because this is so ugly and it's just my brain keeps getting stuck against it. So we're going to make const. Is it an animation? I guess it's an animation. Progressor. Do we want to use a new on this thing? Do we want to use an extra class? I don't think so. We're just going to do something like... No, we do, because we need an instance, right? So we're actually going to build a class. God damn it. We're actually going to do this thing. We're going to call it a progressor. Gonna get rid of this for now. Excuse me. Yep, it's a base component. And then at the end, we're gonna throw it back out. The properties are progressor. So we have various callbacks. Basically this dot on if args if args dot on tick, this dot on tick equals args dot on tick. We'll do the same thing with on finish on tick, on finish, and on abort, right? Then we need a interval interval and timeout. Right. And then, do we want to start it right away? Probably not. So start. And we can probably do a on start as well. On start. Or on begin, on start, on finish, start, finish. Yeah, that works. Start. Right. Start. This dot interval ID equals set interval p handle tick, and we'll do our binding here. The binding of Isaac. Can I do it at the beginning? Yes. Ah, we're already doing it. All right. Handle tick. And all handle tick does is if type of this dot on tick equals function, we'll call this dot on tick. And we can probably put a progress thing in here. This dot progress equals 0. Not timeout. Duration. Duration and interval. Interval. Could call it tick rate. It's fine. And we do a bit of calculation to figure out exactly what's what. So set interval, this dot handle tick, and our, this dot interval. This dot interval equals args dot interval or 0.1, something like that. This dot duration equals args dot duration or 1. Okay. Then we need to do the finish thingamajig. So this dot timeout ID, set timeout. This handle timeout. So the timeout will happen in duration. Should we? Yeah, we should. Let's call these MSs. So we know these are MSs and we don't get ourselves confused. So this will be 100, it'll be 1,000. I've worked in a framework where units were mixed halfway through between seconds and milliseconds. It was just terrible. So this becomes all MSs. And here we will kill this one. Clear interval. Cool. On start, we will also do these things, just in case. Here, progress will progress. Get it? According to when we started. This dot start time equals date dot now. And we will calculate the end time at this point. Well, probably. This pillow slid up the back. So, and instead of all of this down here, we're going to test this thing out. Progressor. So let prog equals new progressor. interval ms equals 250 and duration ms is 1000. So that should get us 4 ticks. And then we'll just do, actually we'll just do this start. So if progressor has already been declared. Progressor has already been declared. Oh. Bugger off. Component before initialization. Progressirator. Clear. Nope. Handle tick, handle timeout. So start, handle tick, handle timeout. Done. Interval duration. Okay. So start handle interval ms. Interval ms. Ah, yeah, we had 4 ticks. Handle timeout. All right. So handle timeout p dot handle finish. Trying to think. Handle timeout. Yeah, let's call it handle finish because we can execute this here. We do all the clearing here. We're executing the on finish handler if it's available, but we can also call this from a abort function. Start abort. Actually, no, we cannot. We cannot because we do other things here. So we still want to clear the interval and we want to clear the timeout. Same in the abort, except here we want to execute on abort if it exists. There. Handle finish. Yeah, this we don't need anymore. So I long press, handle tick, start, handle finish. Handle tick happens only 3 times. So the guarantee is not there that we're handling the tick correctly. What we're going to do is we're going to execute on tick one last time when we hit on finish with progress 1. And then here, console.log progress, this.progress. And progress should here now be relative to start time. So start time, dated now. Let elapsed time equals date.now minus start time. And elapsed time is probably in thousands of milliseconds. No, it's in milliseconds. Sweet. So we can now divide progress by duration, or the other way around. This divided by duration. And that should give us progress. Elapsed time, duration. Yeah. And we should probably fire on tick once at start as well. All right. So progress, we don't actually need to store that anywhere. So we have no progress assignment here. Progress is just relative to the time. So dedudding untick progress. And we'll do a handle tick here as well. This dot handle will tick. And we'll do a this dot handle tick at the end as well. Now they might double up there a little bit. Hey. We've got a progress 0, 2, 5, 5, 1, 7, and a progress 1. Yeah, so handle tick is actually handled pretty well. I don't know if we want to clamp it. So we probably want to do a math.max 1. And by math.max I mean min. Okay. And then here we can do on tick progress console.log progress, and we can get rid of this one. I hold it down. Nope. I put a semicolon in here. I hold it down. Nope. I hold it down and finish. So what we did previously here, we can now do here. So we can call this, we don't need to increment progress ourselves. And we don't have to worry about things, about the index not defined. Yep, we didn't calculate that yet. Sweet. All right. It's actually pretty much all we need. We probably want to do some cleanup around the board, see if we can make them reusable, etc. But that's our progressor here doing its job. So now we're going to hold on to it. Let point deletor equals this new progressor thing. We want to have a liquid interface, a fluid interface. So start should return this, and abort should also. And then here, this dot drag stop. We should do point deleter this dot point deleter if this dot point deleter dot abort. So I pressed abort, but it didn't kick in. Right, let's see if we're not putting an on abort handler in here. So here we can then reset the handle. All right, abort is not being fired. This point deletor. Okay, on abort, yada yada yada. So on board we can just reset the handle back to whatever the defaults are. What are the defaults? The stroke. I think we want to pass in everything that we don't want changed, right? So if I don't pass anything in, I want it to be reset. But in this case, I want to pass in a radius of 0.3. And I want... I'm going to handle these a little differently. Did you... There's two ways I can go. I can have these sets of properties stored as a predefined style and use those and say, okay, we want to reset this point as the current hover point. Yeah, I'm already like overcomplicating it. Let's just do this quickly. It's getting late. I need to zoom in, release. Okay. So if I do this and abort, it goes back to this size, which seems slightly enlarged. Is it maybe supposed to be 2? So 2 is the not so enlarged thing. So if we make it 2.5 as our selection, so we have a selection point. So if we're moving over it, currently this doesn't do the thing. All right. So we kind of want to do this. And we want to do this. Cell point. Oof. Selection point, hover point, So this should fire first. We get closest point on path with a 0.3 cell radius fuzz factor. Then if hover point, so right now we're just going to ignore everything we're doing down there. We should be able to do this kind of thing, right? So what's our hover point styling? And I think previously it was 0.3 and stroke width of 3. Closest index. If half point is update handle. So the IDX is whatever this thing out spits out. So we'll do this for now. So select this. Path is not defined. Path. Let path equals props. All right. So we select this. Path is not defined. Oh. All right. So select this here. Yeah. So this I'm gonna have to refactor now into our new progressor thingamajig. Selection point is not defined because it's a hover point now. Hover point, and it's not being reset. So how about we call this the next point? Next point, if next point this.hovePoint equals next point. Then if next point is not equal to hover point, it's not equal to hover point, we're gonna update the handle of hover point. And I think I think these things here should just be these things, right? So they should just be indexes. I don't think we ever use anything else. So then we don't have to do these index calculations. Don't need that. And here, if half point is not equal to -1 and next point is not equal to half a point, then we want to update this to a 1.5. All right, so that should unhover them or just completely blow up. Undefined is not iterable. 150. No, 150? No. One two-letter 1151. Update point handle. Update input move. 1112. Hover point. What's going on here? I feel like I'm getting deep into the weeds, but I think I'm also restructuring it more sensibly and more at a higher level. So going forward, it'll make more sense. The hover point is undefined. If hover point if hover point, wait, 0, 0, 1, -1, false. If hover point and it's not equal to hover point and or I could just handle it in here. Or I can double check, or I can just pre-initialize hover point as -1. So this dot hover point equals -1. So then it should initially also be set. So half point is 2, next point is -1. Update point. So hover point is, if hover point is this, if next point, either way, hover point will be set to next point, right? Even if next point is -1, especially then. 5. I just pressed S. Did I put S here somewhere? I don't know. Select this. Update point handle. So next, I had 1147. No, 1147. What? Input down. Okay. Ah. Wait. What's going on here? We got this 1147 is actually happening down here. And then we get an error in 1154. Oh, because we were just calling it. Okay, so why we're just calling it here on next point? That doesn't make any sense. So if next point is not equal to -1. Yeah, because -1 is true-ish. And it's still calling this. Next point. Hover point is undefined. How does hover point come through? It's undefined. We're initializing it as -1. Next point should never be -1. So half point starts out as underlay component. No. No. All right, let's try this again. So as I'm moving now. Okay, so that's working now. All right, now if I... oh, all right. Maybe we'll make it last a little longer. So, and we'll do it in shorter intervals like that. Oh. Okay. Now the problem is currently it's interfering with the other thing. So this is our hovering mechanism here, which is actually pretty fine. So this fires off the interval for deletion. So you can delete all of this rubbish. You can delete this. These become fairly simple. These become one-liners basically, right? Right. And we can compactify these further. Long press unlined and do not move insert point. Yeah. So we want to convert this now to a point insertor. So if we get to this, we'll do point insertor. It's our interval is shorter this time. We don't actually need any interval MS here. We just want to use it for its, progress management. And in fact, we're not even gonna. We could do the same. We could revert, do an animation in reverse, grow the point, right? The only problem with that is that we don't currently have a handle for it, so you'd have to insert a handle. But that might be something nice to do later on. On abort. And I think, do we have a on finish? Yes. On finish. So if I come here, on finish undefined. Finish undefined, and then we'll do the same thing with the point insertor. Like that. Abort. So abort shouldn't fire. All right, so this dot running equals false. Start this dot running is true. Handle finish. This dot running equal if not this dot running return. If this dot running, this dot abort. All right, if this running return, if not this running return, and then this dot running equals false. After handle tick is fired. And finally, handle finish gets set in the timeout. And we do the same thing here. So now calling abort. Yeah, calling abort at that point doesn't do anything. And now we just have to do the actions, which were previously done here. So on finish, if this was dragged return, insert point at RC. So now I should be able to select it. Nothing happens. Wait 500 milliseconds. 1, 2, 3. Yeah, can grab that. And now the only thing, oh, I can delete them. Boom. Okay, then I can make a little growing animation if I want to. Not really required. But I think we need nothing else here. So if, maybe I can do this like this. If, do that. Like that, like that. Like that. Abort doesn't do anything here. That becomes this. So this is, it does simplify things. The only thing I would like to do is eliminate the need for this. Because only one of these is going to ever be active. So we could probably merge them into a singular one. Because, yeah, because down can't happen without app. So this always, they always get stopped and only one of these starts. So what if I do this? Progressor. And then here, this the progressor, and then I'll just have one of these. I think that should still work. Oh, okay. And then, boom. Yeah. So update point handle, we'll hide that. We'll hide that. We'll hide these guys. Hide that. One line on those. And press point and move point. So that's the big missing one. All right, I'm gonna end the stream here. Time to take care of Dogo. But drag cages, done. Drag whole line components, done. Not done. Not done, not done, not done. Any of these don't matter anymore. No. So what's important now is delete points on line, because currently it just does this. What we can do is on finish, we'll do console.error to do implement deleting point. Delete points on line, move points on line. And I think that should do it. And it's much more structured than it was before. So if I now make this shrink, boom, implement deleting point, yeah. And we can probably take this down to a second. It's just to avoid accidental deletion. So if you click on it, it starts growing, but if I start moving it within that 1 second, it's plenty to be done, right? And we also want to abort the progressors if we're moving. Handle input move, handle this drag move. This dot, I think I can do if this dot was dragged, we'll do if this progress. We can probably quit out because then we don't want to do the hover stuff. Return. So the moment so if I click on, no, if I select it, right, now do this, now it's dragged. Yeah, you see now the style is gone and it doesn't come back. And dragging it will stop it. Okay, so that's good as well. This is the mess for moving the line, but it's actually not very complicated. It's slowly getting into shape. These are much clearer than what we had there before. And we can probably make them less complex even further. So we probably do this if cell point is not equals -1. So instead of index, here we use cell point. And we might even move this into a function. I mean, it's not super complex. Yeah. All right, I'm very happy with this so far. We're almost feature complete on the sort of basic mouse editing parts, which frankly are the hard part, like changing the line thickness. That's here. That's, you know, anything we do in the inspector is going to be a lot easier. So yeah. All right. Good. Kind of happy with this progress today. Appreciate you guys stopping by. It's always nice to see you guys. The editor is starting to shape up, so if you have any kind of suggestions or requests, let me know. Just, you know, be aware that my first goal is to create something compatible with the CDC editor. Step 1, you know, It's important to me that I can import existing puzzles like this. Step 2 will be to as much as possible export back to fpuzzles. So for you setters that are relying on the solving tools and other tools like Sudoku Lab or whatever can understand fpuzzles data, I'll have an export for that. I mean, I'd love to implement PenPa as well. I saw that the Asylum prefers PenPa for solving, so that's a good data point. I haven't really a lot of oversight of the PenPa community, but I'd love to have PenPa import, export, and all that stuff. So let me know whatever matters to you. You know, there's the Discord channels. You can send me suggestions there. There is the Trello board. There's a link to it on SvenCodes. Actually, there's no link on SvenCodes.com. I think SvenCodes.com has links to most things, but not the Trello board. So I'm definitely going to add a link to that. But it's also, I think it's pinned in the channel, in the Discord channel, web app feedback on the CDC Cracking the Cryptic fan Discord. Check that out. There's also my Patreon, patreon.svencodes.com, and you know, subscribe on YouTube, twitch.tv, and whatever else. It's under SvenCodes. Appreciate it. Take care. See you guys tomorrow, hopefully, and have a good one.